everyone. Good afternoon. Thank you for attending this session. My name is Chengwei Lim. I'm a lead software engineer and UI architect from Capital One. Today, I'm going to talk about module federation and deployment strategy on AWS. Together, how this combination can change the way we work. Here's a snapshot of my experience when working on some large single-page applications. I spend most of my time on waiting the application to transpile during the development phase. I usually wait for 1 to 2 minutes to get my local host running in dev mode. Then I navigate through several screens to validate my feature. Unfortunately, things do not work in the first try. I repeat the same process again and again for many times. Finally, I got the feature working and create a PR. I got a PR merge and it goes into a CI/CD pipeline. Again, the CI/CD pipeline takes a while to run through all tests to produce build artifacts. Sometimes a few tests may fail and we come to know only a few hours later. So the feature is done, but not really available to demo. The story is moved into next sprint. Despite everything my team can do to make sure our feature works fine, sometimes production release may not be as smooth as we like to be. If one feature is not working as expected, we had to roll back and reschedule the entire release. From a developer standpoint, I wish I can just focus on my feature and perfect it without bringing up the entire application every time. It will be a lot more efficient just to focus on one small piece. I can then release the change to production without impacting others. That's why I like to share today. I'm going to take an existing Angular application and use Webpack module federation to import a remote module, which a team can work on it independently. Using the same idea, I also import a feature built by a team who prefers building native web components. Doing this, I can build something without working on the host application or the main application most of the time. Lastly, I'm going to share how to use AWS to host static content of a web application without any web servers. I take the Angular application from Angular website as a starting point. It is an application that already lazy loads modules for two features, customer and orders. Let's add a third feature, products. I want to build this new feature in a standalone mode so that I can deploy it independently. Once it's ready, I import it as a remote module into the main application. I create a new Angular application using the Angular CLI. It has just one module in it, products module. Next, I need to find a way to expose the products module and import the module at runtime into the main application. This is where Webpack module federation can help. Let's explore how to set up Webpack module federation plugin to do so. Angular uses Webpack behind the scene, but you won't be able to find the Webpack config file. Here I use a CLI tool from Angular architects to generate the Webpack config file and update the port number to 4201. In the Webpack config file, I expose the products module and specify the libraries that can be shared in the main application to reduce the size of the scripts. I then run npm start to bring the products module server up at port 4201. Back to the host application, I run the same CLI from Angular architects. This time, I have the host application running at port 4200. I update the Webpack config files with the remote URL for products module. It's pretty neat that I can point to the remote entry.js and use different areas for different modules exposed by the remote host. In this case, I only have one module, which is product module. Then I update the app routing with the alias defined in the Webpack config file to import the module as we enter the route. Lastly, I add the route link in the app component HTML. Let's start the host application, which is running at 4200. It works. The products module is now injected at runtime and become a part of the host application. It's still a single page application, but a module is being loaded remotely. It takes 3 steps to achieve this. Expose the module in the remote app. Create the areas to map to the remote URL in the main application. Import the module using the alias. Here we have a second requirement. We want to add a profile feature. Similar to products feature, profile feature will be built independently, but as a web component this time. There are a few libraries provide boilerplate that makes creating web components much easier, such as stencil and lead element. Here I'm going to create a web component using stencil. Stencil provides a CLI similar to Angular CLI. It sets up the project with all the scripts I need to run the application. I create the new application, which has one component init profiles. Running npm build gives me several different scripts, which include an ES module script file, and I can use it to load the web component into the main application. I start this small application at port 4202. Let's find out how to import the web component into the Angular application. First, I need to enable custom element in Angular by adding custom element schema. Then I use dynamic import to fetch the remote JavaScript bundle. Here's the catch. I do have to add a Webpack magic comment to tell Webpack to leave this as default dynamic import and don't decorate it with any Webpack specific instructions. Step 2 is to add the custom element tag in the HTML template, just like regular HTML element. I also inject a property from Angular component as a web component attribute. It has a specific syntax with a TTR prefix. In this example here, the account number is a dynamic value that coming from the app component and being passed into the custom element. Pretty much that's it. Let's wait for the code. Let's wait for the code to recompile and head back to the browser to see the result. The web component now is being imported as part of the main application. It's pretty straightforward in 2 steps. Dynamic import the remote URL for the web component. Once imported, it will register the custom element as part of the DOM tree and use it in the HTML template as other HTML element. Wait a minute. So far, I've been using localhost with different port number for this PLC. I need a way to point to a different host name depending on which environment it is running on. I use another plugin, external template remote plugin, to replace it with a variable that you can define based on different environment. Now I have deployed both products module and profile component in AWS S3 bucket. Let's update it to the host names. I will talk more about AWS in the following slides. As you can see in previous slides, it's all about getting the remote module or component imported at runtime. If the remote feature is bundled using Webpack, you can import it by updating Webpack config and use the areas. Otherwise, you can import the component using dynamic import or create a script tag to import the script. With this setup, you can easily focus on a single feature that matters. You can run the single feature without the hassle of running the whole application Once you are done, you can deploy this standalone component in an environment that you can demo it to stakeholders. Integration with main application is the last step after this component has met all the requirements and verify. You can test it locally with the main application by changing the remote URL, but keep other URLs mapping to the remote host, such where you don't have to bring out all different hosts in order to get the main application up and running. Once the deployment is deployed, the main application will show the updated content. From the user point of view, it's still a single page application. Underneath, the application is composed by components from different hosts. Let's see a quick demo. I'm going to make a change to the profile component, and the change will be reflected in the main application without making any change to the application when the change has been deployed to my S3 bucket. Here's the main application deployed on demo main app. As you can see here, there are 3 different scripts being loaded for this page. And we have a profile component here, customers within the main app, orders, products, which is loaded from a remote host, and home just take it back to the default page. All right, let's come here. This is the profile application. I'm going to add a full name here. Let's call this as a John. All right, let me remove. Yeah, save the file. Let's build the application. All right, it's done. Here I have a script that will take the files, deploy it into S3 bucket. Cool. All the changes has been uploaded to my S3 bucket. And let's take a look at the main application. Refresh the page. Here it is. The change has been applied without making any changes to the main application or deploy the main application. You may ask, would it be a nightmare to maintain so many web application servers as the number of such small independent applications grow? Let's switch gear to serverless. Serverless means hosting without managing any servers. Let's take a look at what AWS has to offer. Here are a few things we need for a web application. We need a domain name system or DNS to translate the domain name and route the traffic to where the web server is. Of course, we need a web server, but here we have CloudFront as a CDN acting as a web server from AWS. It is a content delivery network that serves the content to the end user. It fetches the content from or where the files are stored, catches it the nearest point to the user to reduce latency. And we need the web application firewall to protect the website from different type of web exploits. Denied service protection is enabled by AWS Seal by default. SSL certification for secure connections is created and imported using AWS Certification Manager. And the static content is stored in AWS Object Storage, which is S3. Here's a full picture. Putting all together, here's a high-level diagram for a fast, secure website without having any servers to maintain. In the previous slides, I have used S3 as a web host to serve my POC. However, it is not really a secure solution. Here in this diagram, I added permission and access policy to S3 to allow only read requests from the CDN and reject all requests from the public. The continuous deployment pipeline can write into S3 buckets when new or updated content is ready for production use. The AWS Certificate Manager is used to create and import SSL certificate so the connection is secure and encrypted. AWS CloudFront is the CDN to deliver the content to the end user around the world at the nearest point to the users. The defense system is provided by AWS WAF and AWS Seal for DDoS. Route 53 translate the domain name and forward the request to CloudFront. Here are some considerations for this model to work well. Use Shadow DOM to encapsulate styles. Limit sharing state and storage to keep the remote modules or component isolated as much as possible so that you can run and test them in the standalone mode. To keep a consistent look and feel, main application and the remote modules need to agree on a common design system. You may also need to enable calls if the remote modules come from a different host. Let's recap what I have shared so far. By the way, I forgot to mention, this is exactly what micro frontend is all about. In the modern single page application, you can compose multiple components at runtime. Each component may be maintained by different teams. Design the infrastructure to support many mini applications is an important step. In this talk, I showcase the serverless infrastructure from AWS that can remove a lot of the maintenance headache when there are so many small applications that need to run independently. This model allows us to work on something small rather than something big and be able to build and test in isolation. It also helps to keep the main application size small, even if there are more features are added. For business, it means faster to market and more features for your customer in less time. Most importantly, no more waiting. I got my time back to study on certification and learn something new. Thank you.
Hi, I'm Joe Weems. Thanks for checking out this video from EnterpriseNG 2021. Online conferences were great, but it's time to get back in person. See your old friends, make some new ones, and take your career to the next level. Head over to ng-conf.org to get your ticket. See you there.